Hey everybody, welcome back to week 4 of the semester. So I guess in addition to the regular weekly exercise, the thing that you need to be doing this week or submitting this week are the technology evaluation topics. You give me an ordered list as a group. I will give you the first topic on your list that hasn't been taken by a group that presents before you. So especially if you're early on the list of topics, which I suppose or the list of, or the order of presentation, which I'll probably email or post in the discussion forum. If you submit sooner, I will fill in your topic sooner and you can start to think about it. But otherwise, I'm going to keep going. I was talking about page speed last week, or at the end of last week. And I guess I said something like, like the thing that I care the most about, that I worry the most about, and I think you should when it comes to like getting the page to the user quickly, which is of course something we want, just the total weight. How many bytes are there to be delivered? And images are a big part of that. So let's come back to where we were there. I talked about, or I mentioned these tools, like some of these automated tools that you can use. Of course, you can just use an image editor to do a lot of this stuff, but these tools I think are useful. And I think the thing to do here is a demo. So I have a couple things here. Let's start with this image, and it's from on the CS page here. It's this background image that's behind prospective students. I just did a somewhere here or in the developer tools or something. I clicked it and show the background image. It's so this is what I downloaded. It's 100 kilobytes or so, and that's not huge, right? That's not a huge big image, but it could be larger. So let's see here. It's that file. I get 107 kilobytes. So looking at my tools here, it's a PNG image. So let's just try. OptiPNG is lossless. The thing that's going to, the thing that ends up taking, or I guess is under control for you in a PNG is often just the number of unique colors. Smaller color palette, less bits per pixel have to be stored. And OptiPNG will decrease that number losslessly. So it won't lose any information. So what I just got there for just running OptiPNG on the image was I went from 107 to 49 kilobytes, half-ish. That's pretty good. And it's lossless. Like I have no question in my mind that this is going to be exactly the same image visually. PNG Quant will have a look at an image. Maybe I can just have a look here. So, there's dithering in this image, right? So there's sort of different shades of, I don't like that view. There's various different shades of pink here. And they are all different, right? They're all different colors as far as the computer is concerned. Where's the, oh, okay. Yeah, there we go. That's better. Like this pink and this pink might be ever so slightly different. So OptiPNG will consider to like all of these are different. We're not going to change anything. PNG Quant will sort of say, well, okay, we have some similar colors. Can we sort of unify things? And what it just did there was not help anything. Same size. So, but now because I'm being a little lossless here, I can say, well, how lossless do I want to be? Like how similar do colors have to be before I allow you to actually consider them to be equal? And it looks like I'm not going to get a huge savings on this. Like what if I turn the quality way down? Let's see here. Like I'm getting a slightly smaller file. It looks exactly the same still. Like those, so it saves under a different name so I can compare. It's a little smaller, looks the same. So what was I? It was 107 kilobytes. less than half the total bytes, just for a couple of automated tools. Maybe I will try here this thing called Squoosh, which is basically the same kind of deal, but online. So that's the one, it's lossless still. So, oh, okay, I don't want it to be a JPEG because it's not naturally a JPEG. I don't know what OXPNG is. I guess, yeah, so these, oh, you can't see that. There we go. It got it down a tiny little bit. Oh, that's better. Yeah, and this, whoops. Like, I don't know what, yeah, I don't know what dials I have on this. Let's come back to that though with a JPEG or something when we get the chance. So like something else I have here was, where did it go? This one. So I downloaded this off the SFU front page last week. It was gone when I looked. Like it wasn't on the SFU page this morning, but still, it is what it is. Point is, this is what I downloaded, and it's a JPEG. You know, if we come back to the fundamentals here, JPEGs for photos. That's what the P stands for. This is not a photo, and what you get is a little compression artifacts. So again, it looks fine at sort of this size, but if you start zooming in, like this should be a nice crisp white line, right? There's a blue background and a white line, but these are the compression artifacts that if it was a photo, if this was a picture of, you know, some trees out, you know, landscape or whatever, this kind of artifact is completely not noticeable. It is awkward and unpleasant in any kind of other image. So I could just save this as a PNG, and I think this is sure. Sorry. Yeah, it got much bigger, and it got bigger because it's a lossless compression or lossless sort of changeover. It's trying to dutifully compress all of these image artifacts, and that's not I don't want that. I want this beautiful background. So let's turn to another tool here. And I found this recently. JPEG to PNG looks pretty cool, and it's basically like, let's try to smooth things out, get rid of the JPEG artifacts, and then convert to a PNG. And my experience has been that's quite helpful. I had to like download and compile it. It's not like it's easily installable. But I think, yeah. Okay, it's got a little computation to do. It does it. It's still really big. But I think, and assuming that I remember what I did last week when I was planning this demo, so like if I zoom in on the same part of the image, okay, so those compression artifacts, and I think you'll be able to see that, you know, even through the YouTube video compression, this is a much smoother line. So those compression artifacts that we're trying to deal with are at least partially gone. Let's see if we can now, what will OptiPNG do? I got a lot of work. It's a relatively large image. An 8.3% decrease. That's not very hopeful. Still pretty big. Let's try PNG Quant. Again, like there's a lot of very subtle shades of blue and white in there that I probably don't care about. Now we're getting somewhere. So I'm still larger than the original, but it looks better, right? Let's not lose sight of that. Again, I almost certainly won't be able to see it because this video is being losslessly recompressed by YouTube, well, by my encoder and then by YouTube again. So that subtle difference between those two images that I can't really see, probably you can't see either, but this image a little bit bigger actually will look better. I think I think I managed to dial down this quality, sorry, and things looked much better. Oh, sorry, things look equally good, and yeah, actually got smaller. So again, like this looks still exactly the same, and I have now a much smaller image. I don't know how far I can push it. Like if things will start to maybe look bad at some point, but geez, not that I can see, right? So at this point, I've turned this 160 kilobyte JPEG into a 600 and something kilobyte PNG into a 40 kilobyte PNG. And all of them look exactly the same from a, from a distance. The PNG that like nicely cleaned up. And I bet like if I could have started with their like, whatever this is, like Adobe Illustrator or Photoshop, like their original without the JPEG compression artifacts image, I bet I could have tucked it a little smaller. I would have won a little bit more on that. But this is pretty generally my experience on images on web pages. If I can't shrink it by half, I feel like I've failed. And I guess I showed this last week of like these random photos from this department website where, again, some software on the server side should have taken that big image that somebody uploaded and said, oh, you're displaying it as a thumbnail, I'll scale it to be a thumbnail. So yeah, making this smaller but look exactly the same, not a challenge. Scale it down by 4 times or something. This page speed deal here that I've linked has this optimize your images section that is a lot of what I just talked about. Choose the right format. And I guess, something I didn't say back there, speaking of choosing the right format, this also could have been an SVG image, right? This could have been scalable vector graphics, and I would have had no pixel artifacts of any kind. Like maybe this should have been an SVG image and not a PNG. And I'm not going to try to trace it because that'll be a mess. But anyway, it often amuses me how like people keep rediscovering this. Yeah, if you have a page with images, and even this blog post or whatever it is here, if I took this image, my experience is, oh, not the link, open the image. Okay, so this seems to be the right size, right? It's being displayed at this size. It is actually this size. Just running it through OptiPNG. A lot of websites have started to do that as some sort of like part of their tooling. So I do sometimes lose this bet on modern pages, but still. And I like this quote. Like, if you want your page to go fast, if it's got images on it, you're going to have to know something about image compression or how images work. There's no way around it. Okay. So moving along, and actually, while I'm complaining about SFU, let me uncomplain. Something like this image that's part of every page on the, everywhere, which I can't, I would have to crank the developer tools up. It is nicely optimized, as I recall. So that's great. Right? Somebody who did know something about images, and I think, this swirly background on this line, those, as I recall, are kind of nicely optimized images. So somebody did take the time for those ones, but the software that produces the pages doesn't do it sort of automatically for anybody else. Okay. So as we come down this list of, again, how do we make our page fast? Okay, I haven't talked about servers, but, have a good network connection, have a fast server. I think that's probably not something I need to spend much time on. These two things, like number of HTTP requests, again, I also mentioned, but this page drawing business, I find is something that web developers do have a lot of superstition about. So the idea here is that if you look at a page, like just the HTML you deliver to the user, these links are the style sheets and scripts that are linked up here in the page head. have to be downloaded before the H1 and the paragraph can be displayed. It's just the rules of drawing a page. But any script down here at the bottom, well, you can display the page and then load the script or style sheet or whatever is linked down here at the very bottom. So we have this choice now of like, basically, are we going to block? Are we going to wait for the style sheet, the JavaScript to download, or are we going to draw the page first? So there's this, like, again, often repeated advice of like, get your scripts linked at the bottom of the page. I think that's overblown. Just have less files, less bytes, minify them, compress them, concatenate them together so many CSS and many JavaScript can be downloaded as one request. I think that's a huge win compared to this like possible slight speed up of downloading before displaying before downloading. The other problem with the sort of lazy loading of JavaScript, and I guess the other thing is there's a flag you can put on the script and link tags that say like lazy load it, don't block on it. So it's this flash of unstyled content or flash of non-interactive content that is the cost. If you draw the page before the JavaScript is there, there's this whatever fraction of a second, maybe more, where the user can start clicking on stuff or start scrolling or whatever, where your JavaScript isn't yet there to do whatever it's supposed to do. That can be really disorienting, and not to say it's always the wrong thing to do to move things to the end of the body, but I think probably not something that should be your automatic first choice. Yeah, I think I will leave this. Sorry, this page throws me every time with this loading icon as an actual image. Like, it's done. I find I sit there and wait for it just out of habit. But yeah, nice description here of some of those factors if you want to have a sort of more complete read of it. And we've all had this happen, right? It seems to often happen with things like ads and stuff, where it's like, oh, you see the page and you start reading and everything moves. Like, okay, I was here. And then everything moves again because the next ad loads or the next JavaScript loads and somehow modifies the page. It's irritating. Again, not to say you can't sometimes get a speed win from it, but be cautious, I think. I think this is one, I think, honestly, front-end frameworks are a huge loss to web performance and to web pages and web usability. If you look at something like the calendar, the Outlook calendar, I don't know what's in my calendar. I'm not going to click that. I did it before lecture. But it's a damn 8 megabyte page. Why is it? Oh, I have to sign in anyway, so let's not bother. Like, it's just my calendar. It's just like basically a table in HTML with my things I'm doing. Why should it be that much? Why should it take 30 requests from the browser back to the client for various pieces of information to draw? The whole thing took like 8 or 9 seconds to get itself drawn even from a warm cache. Like, I didn't even hit Control-Shift-R to throw away all the cached info. It was like most of the JavaScript was in my cache, and it's just a page. It could have been a single honestly, it could have been a single HTML document with a table in it, rendered server side, and then a couple of JavaScript things for whatever interactivity. I think React and Angular and Vue almost always slower. Unless you have this sort of engineering might of Facebook, where you have that much control over how every single thing is happening, and you can put a huge amount of thought and a huge amount of engineering into making the page load very quickly because you've considered every single component and exactly how it's going to fit together and render. I think sending the user HTML is faster. Every time I've tried any of these front-end frameworks, everything gets slower. And more complex, and there's more places for failure, frankly. There's more places where things can break. This is one where I think we've made our lives worse. Just if you think about how long did it take for you to, if you put what you did for assignments 1 and 2 on a web server and you clicked on a link to it, how long did it take those to render? Not very long. It's because they were light and they downloaded really fast. They were not, I kind of want, you know what, I'm going to load this just because it's so astonishing to me. I'm going to pause the video while I log in and stuff. Okay, I've logged in, multi-factor authenticated and everything. So again, this is my calendar, brought up some dev tools, I've cleared them. I'm going to, I'm just going to like go here, I'm going to press enter. I guess I'll click reload because enter doesn't do the thing I want. So like, look at these go by. I'm at 151 requests. Like I said, 10 megabytes, coming right up on 10 seconds. 13 seconds, like it's continuing to load crap as I sit here. This page is not slow because like anything in the browser or the bytes are being delivered in the wrong order. It's slow because it's 10 megabytes to display a table of my calendar. There's no reason it should be. And again, there's all of these bits and pieces of JavaScript that all could have been and should have been minified and concatenated together by some asset management tool, but no, all separate requests, adding up to 153 requests. This is our fault as developers. We have caused this problem by creating frameworks that need, like, how many? I don't even know if I can, like, can I like highlight things or something? And no, like however many JavaScript requests those are, there don't need to be that many, even if they're separate components. Like, everything for Outlook in general could be one JavaScript request. Everything for the calendar could be one Outlook request or one JavaScript request. I don't see why not. This is, we have done something bad as web developers. Stop it. Okay. I'll get off my high horse. So let's assume we have relatively few bytes. Our images are small. Again, we have some kind of asset management to compress, concatenate CSS and JavaScript. Okay, you need a fast enough network connection on your server. Just generating the page, right? So do I closed the dev tools there, but delivering static content that's just a file on a disk is pretty easy. The things that are generated by code, that's where, again, you as a developer have this trap to fall into. You can have a page that generates really quickly or not. Make it generate as quickly as is reasonable. A few milliseconds here and there, probably not a big deal. A few hundred milliseconds, a few seconds, users are going to notice. Depending on the page load, right? If you have thousands of active users, maybe you need a few servers to handle that load. Totally reasonable. And the speed of light is cruel, and I'll come back to that. So there's a couple different, I don't know, people have different assertions of how fast your page should load. It's a sort of small single-digit number of seconds. It seems to be the common advice one way or another. For me, honestly, if I have a page, if it takes more than 1 second, I want to know why. I'm not saying that all pages have to be delivered in 1 second, but it would be nice if they were. So okay, so this is static content, right? There's nothing that should be hard here. If I hit, I'm going to do Control-Shift-R, the complete full hard reload. 12 requests in a little less than half a second. Now, it's close. This might be longer. What this server is, it's West 2, so it's in Oregon. That's relatively close to me. If I was in India or Europe or something relatively far away from Oregon, that might make this a little longer. But hey, I'm pretty happy about that time. There's various tools for this, and this is again where I think I'm just going to take this front page. Why not? This checks things, obviously, that can be automatically checked. It's not going to check like, oh, can that image be a PNG instead of a JPEG? And what if it's not that clever. Or do I really need this JavaScript? Could it be done without JavaScript? It's not going to know that. But it will check things that can be checked automatically. And some of the things that can be checked automatically are the render blocking resources. Things like JavaScript and CSS are at the top of the page in the head, not at the bottom of the page. Okay, so it complains about those. I don't think those are a problem. Yeah, I could be using a content delivery network for some of these things. We'll talk about CDNs in a bit. Yeah, these are things that I should think about. What's wrong with my cache policy? Oh, my cache policy is 24 hours. Okay, so I guess if I change my style sheet, if I change my JavaScript, you might get the old version for 24 hours. A content delivery network or asset manager could help with that. But hey, I'm okay with it. And then for something like, a randomly selected page on, actually, let's use the Google page speed thing for that, just to see it. Okay, it's a little more complex page. There's more style sheet, more JavaScript. It's dynamically generated, so maybe the generation of the page takes longer. Yeah, actually, so it's a mobile view. Like the default is mobile. Yeah, so for whatever, the Google page speed is very happy with this page as a desktop page, less happy with it as a mobile page. I don't, again, I'm pretty suspicious that this is going to take 6.6 seconds to load on somebody's phone. I'm sure there's some, they're downloading at some very, very slow speed that a 51 kilobyte style sheet takes half a second to download. That's very pessimistic, I think. But hey, maybe I should think about that. Maybe those files are a little big. Maybe I think they're served with compression, but maybe that's something to look at. Maybe it doesn't need to be. Something I didn't even talk about when I was talking about images was like, okay, JPEG and PNG have always worked, but there's these WebP and ABIF formats that are newer, better compression, even when lossless. Maybe those are worth it, and maybe I should have tried some of those images. I'm not going to go back at this point, but maybe I should have tried WebP, and that Squoosh, that online tool, will let you compress with those. Not a huge savings here. I think these are it's worth doing a checkup. It's not worth saying, all pages must get a score of 75 or higher. I don't think this is any a magic score that you should take as quality as a developer, but it's going to point out things that you should think about as a developer. And again, are worth it. I like this one because it gave me a higher score, I guess, on a different page. And there's various other automated checkers like the SSL check and stuff. But again, I think those are worth it. They will, think of them maybe as a learning tool, right? They're a way to learn what it is about your page. And so maybe you have to give it some thought, and maybe you decide, you know what, I'm totally okay with that. It's going to take 300 milliseconds because I made this choice, and I'm okay with that. Yeah. Okay. Okay. All right, little side topic here. And that is, I guess, again, it's kind of about page speed, because of course you need to deploy, you need to have a web server in order to have the web thing actually, sent out to the user. But how are we going to do that? And yeah, so this is a little convenient change of topic here, but that's okay. So the sort of, I don't know, traditional way to do this is manually install, right? You have your code base, you're going to copy it over to the server, you're going to install Nginx and some application server and the dependencies and whatever, and off you go. And that's fine. It will work. Like it's frankly a lot of the way, well, not really. Like ggbaker.ca has certainly some manual steps in its deployment. But this can be a problem. Certainly, like, okay, my web server works today, but what if I need to move it? Which has certainly happened to me. Just like I need to move to a new virtual machine or a new data center or whatever. Wait, how did I set it up again? Like I did some manual change 3 months ago. What was that manual change? Or something changed between yesterday and today. Ooh, exactly. I changed 3 configuration files yesterday. Which one, how did I exactly change them? How can I back it out? What if you do need, again, the multiple servers where you have a bunch of things all doing the backend work, like running your Rails or PHP or Django code or whatever? How do you make sure 4 backend servers are all doing the exact same thing? And how do you deal with it if like you have some auto scaling, which is a thing that you can do, that is, okay, well, if the load gets high, turn on another server. Load getting higher, turn on another server. Load is low, start turning off servers. Well, you have to be able to sort of create them in some automated way. So this is where configuration management tools come into play and become important. And the idea here, and this is something you will be doing as the course goes on, in, I guess, really exercise 4, things start. I don't remember what exercise you're doing right now, but yeah, so this is the thing that gets started in exercise 4 and will kind of continue as the course goes on. You write a recipe or whatever it's called, some kind of automated or some kind of, like, I guess, machine readable description of how do we set things up, and then something runs it. So the idea here is this recipe is part of your code. So you have code that is like, when a request comes in, run this Ruby on Rails code to generate a response. You also have code in your repo that is, when a new server gets set up, what do we install and how do we configure it? So you get version control for that, which is great. Again, why did my page break? Why did users suddenly start complaining yesterday that this is happening? Well, it's because of something that we did yesterday. Maybe it's a change in code, maybe it's a change in configuration, but we can see it. And we need a new server set up. Well, run the thing. So the kind of thought that you express in these, all of these, and you could put Docker files in this category as well. They do a slightly different thing, but they're also an expression of server configuration. So you say things like, okay, well, I have a new web server. What do? I install this thing called Nginx. I take this file from over here and I put it over there. That's going to be my server config. And then, I change the server config. So I need to do a service Nginx reload to have it actually notice. And then, I have my application server. So, do this and install the file here and whatever. All of these things become automated and, again, very, very explicit, I guess, in the code base. And if there's a change, so again, this is one where I guess Docker file, this is not true of a Docker file. It is going to be true of these things that configure computers, like virtual machines. You're going to probably rerun it, right? So you're going to change your configuration and say, okay, well, this configuration file, I need one more line in the config file. So check it into my repository, and then on every server, fire the recipe off so that every server gets that change in, this config file, and every server has Nginx reload done, so it notices. The implication there is that everything should be safe to rerun. So something like this, okay, well, I rerun my recipe to get this config file into the current state or the new version. So, everything else here, well, I'm going to rerun this part of my recipe, install the package Gunicorn. Okay, well, let's say if it was installed before, installing it is now a no-op, so fine. Put the configuration file there, also should be no change. Create the directory, set the permissions, rerun it again, no change. But that's important. And this is the word idempotent or idempotent, if you want. Either I learned in some math classes some funny property a matrix could have, I think is more interesting in computer science. It's a word that you sort of need to hold on to because sometimes it's a thought you should have. It basically means that doing it once or doing it twice or doing it 1,000 times has the same effect. So this is like pushing the button in an elevator. I don't know how, there's obviously people in the world that don't think elevator buttons are idempotent. You press the up button, the elevator knows that you want to go up. You don't have, if you press it 1,000 times, the elevator still knows that you want to go up. Same in a crosswalk. Some people need to be sat down and told that crosswalk buttons are idempotent. Press it once and chill. Anyway, but the idea here is that I can rerun my recipe 1,000 times, or I can just rerun it because, some change over here, I can rerun the entire recipe and not break anything. So this is something like if you have a step here that is like move this file from here to there. Well, if you try to run it again, the source file is missing, so that's going to break. You don't want that in a recipe. So it's something like if the file is there, move it. That's safe to rerun. So again, what I was really thinking there as I described that was this version, you have two choices for how to deploy and configure stuff in this course. One of them is in virtual machines. So, oh, wrong. Oh, that link's broken. I'll see what I can do about that. So that's the link I wanted. VirtualBox is a tool that manages virtual machines just on your computer. It creates them and whatever. Vagrant is a tool that gives you command line configuration management control over these virtual machines. So you would install those in this scenario and would write some kind of configuration management. My instructions are for Chef. It's the one that I hate the least personally. And again, gives you a way to say things like, again, this package needs to be installed. The other option, which is Docker. So the idea here is similar. We're going to have probably one thing per container. So container, if you don't know the word, is something like, it's either a process that has its own file system, or it's like a virtual machine but relying on your computer's operating system kernel to get started. It's something, again, think of it either a very small virtual machine or a very sandboxed process. So you're probably going to do one thing per container. You'll have an Nginx container and a Unicorn container and a database container. For each one of them, you start with some container image. Something like, I don't know, you've got a database container and it's the MySQL container, maybe plus some other stuff that you're going to do, but it's going to start there. And then a Docker file is a way to say how are we going to change it? So we're going to start with some container image, and it might be something like I'm going to run Python stuff. I'm going to run Python 3.9. So I'm gonna take this container image, well, 3.9 bullseye, whatever that was, or 3.9. What's my choice? I guess my choice here is what underlying operating system do I want underneath my Python-y things? 3.9 Buster might be my choice. That would be a Debian-based image. And then I'm going to start with that, and then I'm going to install this package and install this configuration file. Okay, that's going to be the thing that I want to run to actually make my application go. And then I will start those and destroy them pretty freely. They're cheap to bring up and down. So once I have this image, I can get bring them in and out of existence quite easily and quite quickly. So that's the Docker container version here. Docker Compose being a tool that lets you sort of deal with a bunch of these relatively easily. So again, here it's the underlying service, I guess, that is being provided by VirtualBox, which is I need virtual machines, and Vagrant, that is, okay, well, we'll manage the virtual machines and bring them up and down as we need to. That's the sort of analogous thing is happening here. I have Docker that's actually doing the thing. It's creating the containers that I need, and Docker Compose that's letting me manage them. And either way, there's a template that you can use, or I guess you can ignore if you want, but somewhere where you can say things like, okay, well, I'm going to have something called web and something called database, and here's how they each get built and destroyed. And I guess the other benefit here is, of course, this is not a one-person problem in general. I guess it is for exercise 4, but as time goes on, this is, you have a bunch of people working on this in your team, company, group, or even just on the server. And as you're developing, you want to be able to fire up an installation of your code where you can make things work, and then have some assurance that they're going to work when they go into production on EC2 or whatever. So we're not doing the actual deploy thing here. And I know some people that teach, I don't know if Bobby does in 470, but there is this option of like, I could make you deploy things on some cloud provider. I personally don't think it's worth it for a course. I think if you can write the chef recipe or the Docker file, I think that's good enough for me. But there are these cloud providers where you can actually say, okay, well, here's my virtual machine image. That's what I mean by web server. I need them. Go. But again, I think I would take that choice to simplify, and have taken that choice to simplify things. But we're going to get started on that in exercise 4. Okay. That is what I want to say about page speed. Again, with this, like, not quite about page speed footnote, but we need to do it in the course. And I'm going to move on to databases. So you have taken a database course, that's the rules, but we need them. They're going to be a big part of how a website works, I guess, at least if it's a dynamic site, which it's going to be for us. A user comes along and they want to display their account information or whatever. Well, I need their account information, and I need to take it out of wherever I store it, turn it into HTML or a JSON object that I can send off to them. Or if they order something, of course, I need to write. It's exactly what a transactional database is all about. Good thing we have them. And I guess I use the word transactional there on purpose, right? So the kind of thing we're doing here, if these are terms that you've come across, I don't know what happens in 354, to be honest, but this is, we're looking for like some very specific records, or we're going to write some very specific records kind of one at a time on demand. We're not going to do like batch processing like you would in like data science, data mining kind of context. If that's relevant to your understanding of databases, this is where we are. If not, whatever, we're using databases. So this is, like I said, this is what databases are good at. We've got them. That's great. I'm going to review a couple things that I hope you know from the databases course, or whatever, somewhere in your life up to this point. Data normalization. You want each fact, each thought of whatever you know about the world to be stored in exactly one place. If you don't do that right, if you have something like, my address is stored here and here and here, like, you've written enough software now to know that like eventually you're going to, of those 3 copies of my address, you're going to update 2 of them. And it's going to then be a nightmare for the rest of time to try to figure out which one's real. Don't do that. Normalize things. there are reasons to denormalize data, but you better prove it's necessary before you do it. Keys, indices, primary keys, like all those kinds of things, that matters. And I hope this is a meaningful thing for me to say. The problem is, and I've seen people do this, it doesn't matter when you have a dozen records, frankly, right? If you have some little piece of test data and you have, again, 10, 100 records in your table, these both look the same. They both are as fast as you can possibly hope for. You'll never notice the difference. But then you're going to have 1,000, 10,000, a million records in that table. You hope, right? You hope you're popular. All of a sudden, order N is a nightmare. Like this story that is over here. Let's assume his name is Bobby Tables. This is like, oh, we need this, like, please wait dialogue because these things take so long. I'll summarize the story for you. And dude, like, who was like an intern, looks and is like, there's 2 million records in this. It's oldie times. The CPU is slow. We're joining all this stuff together. There's just no keys, no primary keys, no indices. Added them, and the thing that used to take like whatever it was, minutes, like possibly like 8 or 10 minutes, all of a sudden is 0.22 seconds. And obviously this is the complete right reaction to that, which is I have somehow done a delete star from the database kind of operation. There's no way it could possibly be that fast, but that's the difference between N and log N as the numbers get big. I think it ends here. They literally threw him a party because some intern that had taken a database course knew how to add an index to the database table. It matters. And this is something that is going to be a little bit obscured by like object relational mappers as we go on, but you need to keep in mind that it's in there. The other thing that can go on is that, like, just doing a query, no matter how much data it returns, takes some little bit of time. And it's very easy to do this. And I'll talk about this when I talk about object relational mapping in a little bit here, like later on today. But it's very easy to end up with basically this logic, which is like, what are all the orders? Okay, so for each order, find the clients that go with it. That's n+1 queries. And this n+1 queries problem, again, you won't notice it when there's 12 records. When it's 100, like even like 100 records, and you're doing 101 database queries to build this page, is noticeable. Again, it's going to be obscured, but you need to know. And this, again, I've seen developers miss this one because it's easy to miss in the context of an object relational mapper. This is much faster, doing one query. Very, very different timing. So, like, keep your eye out for this. Remember that many small queries are often slower than one reasonably constructed big query with appropriate, indices and stuff in it. Keep that in mind. So I'm going to say, okay, SQL, I assume from some database class. We're going to use it. We're probably not going to use SQL very much directly. We're going to use an object relational mapper to map program logic onto the database, but you need this abstraction in your head. You need to know what's actually going on there, and I will talk more about that later, presumably after the break. Take a break here. Oh, no, I won't. Sorry, I forgot what class I'm recording for. I'm going to keep talking. Pardon me. My other class is a 2-hour lecture. This one is 3. Okay, sorry. Again, somebody else would edit that little bit out. I'm just going to take a moment and keep talking. Okay. We need a database. Probably it's going to be an independent database server. You could pay for a database server if you want. Like, we can do that. Like, if you would like to give Larry Ellison a bunch of money, yeah, you can put your stuff on Oracle. But I don't know why. The open source databases are very good at what they do. the sort of default choices for like SQL relational ACID database, like standard database as we all understand it. MySQL and Maria. So MySQL has been around forever. Maria is a like more open source fork of it, but I think for my purposes, we'll say those are synonyms. Postgres also been around for forever. They're both very, very good at what they do. They're very good at being databases. People have deeply held convictions about which one is better that I cannot find any hard logic to. I will say Postgres seems to be better at like database geek databasing. Like the sort of things that are in the database textbook were better supported by Postgres earlier. Just things like transactions and, you know, all the ACID guarantees being exactly just so have been better in Postgres, historically at least. One thing that Postgres does have, you can do a schema update in a transaction. So you can do a like begin transaction, modify a table, modify another table, modify another table, and then commit the transaction, which means if you are modifying a production database, you can have this, again, it's all or nothing assurance of a transaction, which MySQL doesn't do. It will just modify 1, 2, and then the third one fails and you're like half updated, which could really suck. That's the only reason I would prefer, that I have seen that is like concrete, I guess, that I would prefer Postgres on. There's some other stuff in there. Again, Postgres tends to have more features. If you're a GIS geek, the PostGIS is probably a complete win. These JSON and JSONB data types where you can have sort of unstructured data as part of your structured table. I don't care. Again, between those two, I don't care. They're both awesome. The other thing that we can do in the modern world is not have a database server, or at least not run our own database server. Let Amazon do it. Let Azure do it. Let Google Cloud do it. Yeah, sure. Those are great. I mean, they're not free. You know, you're paying for this service of having like Amazon relational database server service take care of your database, but maybe it's a win. Maybe you don't want to worry about like the new MySQL version and I have to update for some security patch or whatever, or how do I performance tune Postgres for this situation with these disks or whatever. Maybe you would just much rather let Microsoft do it for you or whatever. That's great. I will talk about cloud services more later on in the course. These things are all mutually dependent, and I just had to pick an order. Do it in this order. The other thing you might want, like depending on your development environment, if you're developing with like Docker and Docker containers, like setting up MySQL or setting up Postgres is not a big deal. But maybe you don't want to deal with it. Like maybe it's just not worth having that set up for just like, I want to write a few lines of code. I want to play with a style sheet. I want to reword this thing on the page or whatever. Maybe it's not worth setting up your real database for that. Again, depending on how you're developing. So something like SQLite, again, I don't know if you've used it. I feel like if I was teaching 354, it would be like, okay, well, let's just use SQLite. That seems easier. You can do SQL queries on it. What more do you want? SQLite, basically, a database is a file. So there's no separate database server. You don't make a network connection to it. You just have a file on disk that is all of the contents of your database. And then you use a SQLite, I don't know, tools, library, functions to do SQL queries and have transactions and, you know, again, all of the things you want from a database, but there's no server, there's just one file. I really like SQLite to develop with, even just because you can do something like you have like, you know, system.db for your database. It's just a file. So you can say, well, you know what? My database is in a good state right now. Copy that file, make a backup of it, and then do something that might completely screw up your database, load some things and you realize, oh, yep, that was stupid. Well, copy the backup back over top of the database file, and you're back to that nice pristine state. It's so easy to do that kind of thing with SQLite. It's nice to have on hand. It's not, you're probably not going to have multiple servers all hitting a single SQLite database. You're probably not going to want to make 1,000 requests per second to a SQLite database, but for development, it's awesome. I actually saw some article the other day, like your phone has SQLite on it, your car has SQLite in it, the plane that you last flew on probably has SQLite in it. I think the stat was like apps that use SQLite, most of them don't write to the database. They effectively just distribute this SQLite file as like configuration almost. It's just part of the thing of like, here's a file, here's a bunch of like configuration or a bunch of like data that we need for our app, and it's basically read only within the app, which I thought was really interesting. Anyway, those are tools that I think you should know about. They're cool and they're handy, and they will make your life better. And again, depending how you're working, maybe you're going to work all Docker all the time and not switch between databases, between like development and production. I think with a modern object relational mapper, it probably doesn't matter very much. So in a databases course, probably in your databases course, there were these like, okay, there's probably some exam question, right? I have no idea. Like, I'm just going to make up what I think might be in a databases course. But there might be some kind of like, we have these 4 tables and we want to find all the data, this, that, and you end up writing this big join, and there's like, this is a left join and that's a right join and that's an inner join, and we have to get them all right to get full marks on the exam or whatever. But that's not most database access. Most database access is like, I'm gonna have a table. If I have a foreign key, it's going to be a straight up artificial, simple primary key, like not a compound key. Again, another thing, it's a good database course thing to be like, oh, what compound key would you make up for this data? And I think the answer should be, no, I'm not. I'm going to have an artificial primary key that is not compound. It's just, I have an auto incrementing integer. That's how I refer to rows in my table. That's my primary key. So, okay, my join is now much simpler. I have a very simple join. Like, I've written SQL queries where I had to do like the primary key was 4 parts, and I had to say, well, where all of these things are equal in my join, and that's annoying. Much easier to say where like foreign key ID equals key ID. And then have your join. And the other thing you're probably going to do in the modern world is have an object-oriented kind of view of your data in the programming language, where you're going to have like a table of orders in your database, and you're going to have a class order or objects of class order in your code, and like there's an obvious relationship between those two things. That's probably all the database work I'm going to do, and you can do it. Like, I have faith that you can do those things. They're just not exciting. So you have some situation like this, right, where there's an artificial primary key on the database table, kind of reasonably nicely normalized things. And if things are nicely normalized, I'm going to have these foreign keys where I have like, there's another table called department. It has a column called ID, and row 7 in that table is the department that this person goes with, or this employee goes with, or whatever I'm imagining here. And then in your code, again, like, so you sort of think about the databases course and you design this, and then you think about 225 or like some data structures and programming course or whatever that is called, and you think, okay, well, in that course I would have designed a class, and that class would have been person, and it would have had properties or fields, first name, last name, department, and that's going to be a department object, and I want to save it and write this record in the database, or I want to be able to read this record from the database and like reconstruct the object. that's totally a reasonable way to interact with a database from some kind of application code. And this is what an object relational mapper is going to do. Again, that's not hard work, but it's boring and repetitive work. An object relational mapper, SQL object is probably not the world's best object relational mapper. In fact, it's definitely not. But what it does have is a really nice like front page example. We're going to create a class person. And it's going to have, so this is Python code. So this is a new class person. It is a subclass of the SQL object. Right? So it inherits some magic from the superclass. It's going to have these properties: first name, middle initial, last name. And I'm going to create a table. Okay, so that's going to do some kind of like create table with this and this and this. And, you know, maybe I get a primary key here, maybe I don't. I guess I could actually, like, so in the code here, it's actually creating just an in-memory temporary SQLite table. I could actually copy and paste this code, but I'm not going to. But then I have my class. So I'm going to create an instance of that class. Okay, so it must have a primary key because it's being used here in this example. It looks like in SQL object, things are being saved automatically. Like in every other object relational mapper, there would be an explicit like p.save step kind of after this line, but apparently not here. But yeah, so create this person object, and then I can go and find them. They have primary key 1, so I can find them by primary key if I want. That reconstructs an object with all of these fields sort of as they need to be. I just like that this, if nothing else, it has this really nice example. Again, it's like connect, like I have a table, I have an object, or I have classes, and it's very obvious how those things are going to go together. I have a column fname and I have a property fname. Put them together. I don't want to write that code, and I don't have to write that code. So this is the I don't know. Maybe this is SQL object code. Maybe I made this up, but this is the kind of thing we end up doing, right? So create the object, put all of the pieces together. So if I say this field in my object is a reference to this object that maps to a foreign key relationship in the database, and save it and search. Again, this implies some select query, but I don't have to write the select query, which is great because that would be boring. You'll see once in a while, like some blog post, some Hacker News post, or whatever it is, that is like, here's why ORMs suck. And it's like, oh, ORMs are slow, or ORMs made my database crash, or whatever. Right, this is 115 slides in a slide deck. I'm not going to flip through them. The problem with an ORM is it's an abstraction, and all abstractions are leaky. This is like, if there's any link that I have in the most possible places, in the most possible courses I teach, it's this one. An ORM is an abstraction of a database. If you don't remember that, if you don't remember that there is a relational database, there are SQL queries, there are indices and primary keys and columns and all of those things, you're going to do stupid things with your ORM. That's not because the ORM is bad, it's because the abstraction leaks. So that underlying abstraction that there is a database, you just have to remember it's in there. You mostly don't have it, maybe not even something you're going to see in the code, but you have to write better code because you know that that's happening. So like the example on this original blog post is TCP. If you've taken a networking course, you just know about networks. TCP is this reliable stream protocol that we all use for the internet all the time. It's meant to be reliable, but it's built on top of an unreliable network. So, oh yeah, TCP is reliable, except it's not, because it can't be, right? If we build a TCP connection, like if an occasional packet gets lost, it will take care of it. But if we build a TCP connection and then I go and I unplug my network cable, well, it can't deal with that. There is still this fundamental unreliability because of the abstraction it's built on. And again, we have this fundamental abstraction going on here. we have to deal with it. So you have to remember, indices are a thing. How many queries am I implying by the code that I'm writing in PHP or whatever? All of those matter. I'll come back to those. And I think I can leave those. Okay, this is, I want to talk about this, but I want to give it the time it deserves. So I'll take a break there for the course that I'm teaching. That's a good spot to break, and see you in 10 minutes or so, or whenever you choose to watch the next video.